All right, C and D are complex fractions. So this is just a little bit of factor and cancel as well once you have your fractions in the right form. So there are two ways that you can set this up. If you like flip the second and multiply, here is the guy you're flipping. So that's one way that some of you like to approach these problems. If you like to group, which I kind of favor, I like to do it this way, and you group the top and the bottom, that becomes the top of your new fraction, and the middles become the bottom of your new fraction. So go ahead and whichever way you like, pause the video and get your fraction set up. Also, go ahead and factor those trinomials, and then when you come back, I will bust through that and you can check your work. Okay, hopefully you'd have that factoring done. I'm going to go ahead and group here or get my fractions all set. There's my numerator. And my denominator, all ready to go. So now this is absolutely just a factor and cancel problem. I'm going to go ahead and bring down my x minus 2 and my x plus 2 because those aren't going anywhere this step. Two numbers that multiply to positive 21 and add to negative 10 to factor this guy in my numerator are going to be x minus 7, negative 7, and x minus 30. So two negatives, add to a negative 10, multiply to a positive 21. In my denominator, x squared plus 4x minus 21, I'm going to use 7 and 3 as well again, but to add to a positive 4, I need a positive 7 and a negative 3. So the beginning of this problem looks worse than definitely problems A and B, but it was a lot fewer steps. We can cancel our x minus 3's. Our final answer is x minus 2 times x minus 7 over x plus 2, x plus 7. All right, let's do another complex fraction. Again, you have some options here. If you like to flip this guy. If you like to group, top and bottom become the top of your new fraction. The middles become the bottom of your new fraction. Go ahead and pause the video and make that happen, and look for some factoring to do as well. All right, hopefully you're a couple of steps ahead of me. Here's what we've got. 5a times 4a plus 12 is my numerator. And my denominator is 15a times a squared minus 9. You're welcome to factor as you go. If you factor kind of in the middle there, you absolutely can. I didn't. I'm going to factor in my next step. So in my next step, 4a plus 12, 4a and 12 have 4 in common. So when I bring that 4 out, I'm going to multiply it with 5a. So that's going to give me 20a on the outside of my parentheses, and I'm going to have a plus 3 left. In my denominator, I have that 15a on the outside. I don't have anything to GCF out of a squared minus 9, but I can do a squared minus 9 is a difference of squares. And now let's see what we can cancel. Well, pretty nice that we can cancel our a plus 3's. Also in the numerator and denominator, we have a, so we can cancel those a's. And we can reduce this fraction, 20 over 15. So 5 goes into 20 4 times, and 5 goes into 15 3 times. So here we have 4/3. And in the denominator, we have a minus 3. We don't have anything left in the numerator with that 4. So there's your answer. You guys know how much I enjoy complex fractions. So thanks for hanging in with me on that. On to the next concept.